further. Okay. Yesterday we were discussing some terminology, some theoretical topics, terminologies, which we saw practically initially in a program, and then we started seeing the theoretical part of it. We saw the subsections of a C program, or structure of a C program, general structure of a C program, and we saw the examples. Then we saw the character set of C programming language. What are the subsets, letters, digits, etc. Special characters. Then we learned a terminology called token, the smallest individual meaningful unit in a C program. Then the categories of tokens, keywords, identifiers, constants, string, operator, etc. And keywords are reserved words, essentially the vocabulary of C programming language. Reserved words, example int, float, return, void, etc. And we cannot use them as variable names or function names. Keywords, there are only 32 keywords in C, and we cannot use them as variable names or identifier. Identifiers are names of variables as well as functions. So at the moment we have seen few functions only. So main is one function, printf is one function, scanf is one function. We have seen the names of functions are identifiers, and similarly the variables we declared x, y, sum, etc. in our program. So those are variables, and they are also coming under identifiers, variable names and function names. Then constants, string, anything within double quotes is a string, and constants are these. Even this is also a constant, string constant. Then operators, these are the subcategories of tokens. Then we went into the details of keywords, reserved words. There are 32 keywords. We know already some of them. Then identifiers we saw slightly in detail. Rules for creating an identifier. What are the valid? What is a valid identifier? What is not a valid identifier? We have seen. So you should remember those rules, and you should be able to differentiate between a valid identifier as well as not invalid identifier. Then constants, even though it falls under SLE, we just saw that okay, how it is hierarchically organized. Numeric constants and character constants. Numeric constants include integers or real numbers, real constants, then character, single character as well as string constants. Then we saw variables specifically, and variables are used for storing data. Variables are names in a program that may be used for storing data. So we have already created variables for storing our input values in the case of adding two numbers, and also for storing the result. That also we have practically seen. Hope everybody understood all these things. Then rules for declaring a variable or naming a variable. This is very similar to rules for naming an identifier, because variable is essentially an identifier only. So it should not start with a digit. You should not use any symbols other than underscore. Such rules are there that also you can read and understand. We already discussed. And we just started or mentioned the topic data types in C. So data types essentially means type of data, the types of data that we use in our C program. Okay, what are the types of data you have already seen? In the program for adding two numbers, we have seen the type of data integer. Type of data was mainly integer, two input integers, and the result is another integer. Then for adding floating point numbers, we saw the type of data float, or basically generally I can say real numbers. Okay, so for creating a variable to store real number or a floating point number, we use the keyword float. For creating a variable for storing integer, we use the keyword int. Okay, so these are basically two data types, and these are not all. So other data types are also there, and we already saw some of them. Okay, or okay, already. So the So we'll see the list of these data types. So every data used in a C program must have a type associated with it. Okay, and that is referred as data type. Okay. And if you say take this one, 25, it is of integer type. As you see, you can understand it is of integer type. It's an integer constant. Type of it is integer. This is a floating point number or a real number. Okay. So type associated with this floating point data type. And since the data is normally stored in variables, we normally store data in variables. We specify data type of a variable when we create the variable name, or when we create or declare the variable, we specify the data type. What it means is, when you want to create a variable, you have to specify the data type. Data types integer is represented using the keyword int. Data type floating point numbers for data type of floating point number data type is used represented using the keyword float. So when I want to create a variable for storing floating point number, I have to use the keyword float before that variable name. So once I create this variable, I can use it for storing data. That is the essence. Okay. So the data types in C are categorized. There are several data types. So they are generally classified into three categories, and I can say primary data types, or they are also called fundamental or basic data types. So primary data types, derived data types, user defined data types. At the moment we are going to focus on primary data types. Okay, we already saw two of them and we'll see the others also. So these are the categories of data types. I can say data types. See data types categories. Coming to primary data types, again there are 5 primary data types in C. These are theoretically the 5 primary data types in C. And the first one is and again they are grouped into integral type, floating point type, etc. But these 5 types are 1, 2, 3, 4, 5. The first one is integer data type, and the keyword corresponding to that is int, or integer data type. The C programming language keyword corresponding to that is int. So this is what you see there. Okay. Then second one is character data type, and the keyword for that is char. Third one is floating point data type, and floating point type, so they are grouped under floating point types actually. So there are two types of floating point numbers or floating point data types, two variants of floating point data type. One is float, or one is represented using the keyword float, and the other is represented using the keyword double. Both are used for, and the name of the data type I can say double precision floating point. So floating point represented using float data type, which we created here using the keyword float, and double precision floating point. If we want to create a variable of this type, we have to use the keyword double. If you take the list of keywords we saw before, 32 keywords, double is also there, char is also there, float is also there. And the fifth one is void. We'll see each of them. Any doubts so far? So this where data types are basically, if you want to store some data to process in your program, or input some data into your program, all those data will have a type associated with that, and to store that data in the program you have to use the specific type of variable. For integer data type you have to use integer type variables. For floating point data or real number data, you have to use either float data type or double data type. Here we have used float. This is what it means. So to store each type of data, we need to create variables of that specific type. Is it clear or any doubt? In this class we will be discussing some very fundamental concepts which will be helpful throughout this course, or which are needed throughout this course. So it is important for you to understand these concepts pretty well. And if it is not clear, you have to ask me. Okay. Yeah, double is also used for representing or storing real numbers. But there is a small difference actually. Float is used for lower magnitude or lower precision numbers. Basically small real numbers, I can say. Reasonably small real numbers. Double is used for somewhat very large real numbers. And how it is differentiated is the memory. So basically data is stored in the memory, right? Computer memory. So for a double floating point variable, we will allocate or we will reserve less memory. For a double precision floating point, we will reserve more memory, so that we can store large numbers in double type variable and reasonably small real numbers in floating point type variable. That is the only difference. Okay, then finally there is a, so any other doubt, like this way you have to ask doubt, otherwise I will not come to know like what did not click to you and what clicked to you. Okay, so some basic conceptual things are covered in this, and essentially you got so these are the basic 5 types of data types. They are called primary data types or fundamental data types or basic data types. 2 plus 2 plus 1. Okay, so we'll see each of them specifically. Uh, Before that, I'll take you a very basic diagram of a computer system. You must have seen this diagram somewhere before. Even in the videos I asked you to watch in the initial first class or given in my web page. So in that also there must be it must have shown this kind of diagram. In that PDF also it was there. This is taken from the PDF, I think. Okay, so these are the major parts of a computer system. There is uh, input devices which we use in a typical computer system are keyboard and mouse. Then there is output device in a computer system. Display is the main output device which is relevant in our context. Otherwise your headphone or speaker, printer, etc. also are output devices, but what is relevant to our context, input device is primarily keyboard, output device is display. Then there is a secondary storage and there is a main memory. Okay, main memory and secondary memory, and central to all of these components there is a central processing unit. This is the heart or brain or core part of a computer system, central processing unit. It is also called a processor. So in your mobile there must be a processor, Qualcomm, Snapdragon or MediaTek, so and so processor. In your computer system there will be a processor from Intel i3, i5, etc., or from a company called AMD, Athlon, etc. Okay, so that is the core fundamental part of your computer where all the execution takes place. Everything, whatever program we do, it is executed in the processor or executed by the processor. And operating system is simply a manager for the whole thing, manager of all these parts. Operating system, it's a software, but CPU or processor is a hardware. It is where everything is executed. Okay. Now I'll come to the context of our program where these things are relevant in a program when we are typing it and saving. When we type a program and save it, it is stored in the hard disk. So hard disk, for a computer we call it as a hard disk, In case of memory, it is flash memory. In case of smartphone, it is flash memory. Then CD, DVD are also secondary storages. In our context, since we are programming in a laptop or desktop environment, the program will be stored in a hard disk typically. Okay, so it will be stored as a file. So what you see in your uh, mm, this is the location on my hard disk D drive. All these things are files. When I say create a file and save it, create a program file and save it, it is stored as a file in the secondary memory. If I restart this computer, these files will still be there. That is a hard disk is a persistent memory. Even if we power off and again later switch on the machine, no data will go. This is similar to your flash memory in your mobile. If you download a song or a video or a movie and you restart your phone, it is still there because it is permanently stored, and even if you power off, it will not go. Okay. So when you first type a program and save it, it is stored in the computer. When you compile that program and generate the executable file, it is still stored in your hard disk. It is still in the hard disk. All executable files you can see here, and my program files .c files also you can see here, and the intermediate file object files are also there. Now when you execute, what happens when you execute a program? Say when I here how I execute, I click on this play button, or double click also you can execute. Okay, but it will not show you the output. It will simply quickly execute and stop it. So preferably you execute from here. Okay, now when I execute, what happens is the executable file, that is the only requirement for executing a program. For once you generate the executable file, you don't need .c file or .o file. We need only executable file. So when you are trying to execute a file, execute a program, it is first copied into the main memory. So from here to here. So in our program scenario, we used already this. We used this because before executing any program, it has to be copied into your main memory. In your mobile, it is the RAM. So even if when you are installing WhatsApp in your mobile, where it goes into the secondary memory, that is a flash memory. But when you are clicking and starting that program or starting WhatsApp application, it is first copied into the main memory. From there, the CPU is executing. So it is between the CPU or the processor and the main memory all the time. The same flow happens in the case of a computer system also. Even a smartphone is essentially a small computer with some specific purposes. Okay. So files are created here, but when you are executing a program, it is first copied into the main memory. Then CPU access every instruction and data from the main memory and execute. Now if you are entering numbers, say in between in my program, first it asks user enter two numbers to add. So when that instruction is executed by the CPU, it looks at the input device and we are going to enter the data, say two numbers. So input device is also involved. Then that data goes to the CPU. CPU already has the command what to do with that data. Say add those numbers and store where to store all those result, etc. And when we are printing the result or displaying the result, the output device is involved. So in a program cycle, typically in a program cycle, your secondary memory, primary memory, CPU, input device, output device, all are involved. Okay. And whenever you execute, once the executable file is copied into the memory, it is between the secondary storage is not coming into the picture after that. So it is between CPU and the main memory, and also if there is an input device, input data, input device is involved. Then if you want to display something on the screen, the output device is also involved. This is some fundamental information. You already know this block diagram. You must have seen in your before also. But in the context of a program, what these components means, what these parts of the computer means. That's what I was trying to convey. Is it clear? Okay, hope it is clear. Now, what we are discussing was in the 5 primary data types: integer, character, floating point, double, and void. And there is a concept called size of a data type or variable. Size of a data type or a variable. What it means is, size of a data type or a variable refers to the number of bytes occupied in the main memory. I can say main memory. When I simply say main memory, I imply main memory only, or primary memory. It's also called primary memory. And here, okay, one thing I forgot here is secondary storage is persistent storage. If you switch off the machine and switch on, whatever stored in the persistent secondary storage will remain there. But whatever in main memory, it will not be there. So this is not a persistent memory. As long as your system is on, powered on, the data will be there. The moment you restart, the data will be lost. Okay. So this is a volatile memory. It's also called a volatile memory or non-persistent memory. So as long as power is there, it will retain the data. Otherwise, it will flush out or delete all the data. Now, size of a data type means the number of bytes. The memory is having a unit in multiples of bytes or its multiples. This also you are already familiar. What is the size of your mobile phone, smartphone, what memory or storage? Normally it is say 32 GB, 64 GB, 128 GB, the storage capacity, right? 32 GB, 64. That is the size. That is the size of the secondary storage. In fact, 32 GB, 64 GB, etc. It is the size of secondary storage or your persistent storage. And there is another thing called RAM, right? Your primary memory in your mobile. No, typically it will be 3 GB, 4 GB, etc. GB stands for gigabytes. It's actually a higher unit of bytes. Okay. So in computer memory, the memory I can tell you the units of memory. Units of memory. So the basic unit is a byte. Okay, bytes are made up of bits. So 8 bits is 1 byte. Then 1024 bytes make 1 kilobyte. And 1024 kilobytes make 1 megabyte. 1024 megabytes make 1 gigabytes or GB. And your RAM is normally 3 GB, 4 GB, 6 GB, etc. Then 1024 GB makes 1 terabyte. And typically a computer these days, the hard disk will be of 1 terabyte size. Storage capacity. Size means storage capacity. Okay, how much of data you can store. Because file will have typically some size, right? Your movie is 1.2 GB or 700 MB, etc. So how many such movies can be stored in the hard disk depends on the size of your hard disk. So if it is 1 terabyte, you can store a lot of movies. 1 gigabytes, maybe very few movies, like that. Typically we will have in these days the computer systems or laptops come with 1 terabyte GB or at least 512 GB. 512 GB or 1 terabyte TB, 1 TB or 512 GB, or sometimes 2 terabytes or 2 TB, etc. Now when we are talking about data types and variables, we have to talk in terms of bytes only, because when we create a variable, we need to store some data. For that, some memory should be reserved in the primary memory or in the RAM. Some number of bytes should be reserved in the RAM. So that is called size of a data type or a variable. So when we create an integer variable, how many bytes are reserved? We don't need megabyte of storage for storing an integer. Typically 2 bytes or 4 bytes for storing an integer. Okay. The size of a data type refers to the number of bytes occupied in main memory when you create a variable of certain type. That is all. Now I have an example here. I have created int x is equal to 1. X is the variable. The value I stored in that is 1. So if when I do that, the binary equivalent of 1 is stored in the computer memory. Computer memory is a hardware, and their data is stored as ones and zeros only. Okay, so this decimal representation or this character representation is for the user, but in the hardware, in the computer level, computer knows only ones and zeros. So when I do x is equal to 1, the binary equivalent of that, so basically this will be stored in the computer memory. So RAM I can visualize as a series of bytes. This is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte, like that. So I am visualizing RAM as a series of bytes. When I create a variable, say integer variable, typically 2 bytes are reserved for that. Not always, but some typically, and as an example, 2 bytes are reserved for that, and that data stored in that 2 bytes is the binary equivalent of 1. So binary equivalent of 1 is this, and here if you see, I have stored, or I am representing, it is stored in this memory. Okay, is it clear? Any doubt? Now when you create a character variable and initialize it with, say, a character value, its binary equivalent, even this character has a binary equivalent in with using zeros and ones, and for typically for a character variable 1 byte of memory is only required, and I am showing it here in 1 byte. Is this clear? Any doubt? Vaibhav? Vaibhav, any doubt? Okay. So size of a data type essentially means how many bytes, if you create a variable of that data type, how many bytes are you reserved for it in the primary memory of the computer system. That is what size of a data type means. Okay. I can quickly show you a program. Which tells for each basic data type how many bytes are reserved in this computer. In the computer I am using, for each basic data type how many. So for that we can use something called size of. It's called, even though it looks like a function name like printf, it is categorized as an operator. Operator typically will have a symbol like plus, minus, etc. But size of is also categorized as a operator. Now size of, and in the bracket I am putting int. This is going to give me what is the size of integer data type, or if I create an integer variable, what is its size. So I am going to execute this program. Okay. So my first statement is size of int is %d and a slash n. Slash n is for new line. Size of int. When I get how many bytes. When you create a integer variable, how many bytes will be reserved. That's what I get. Size of int is 4. The output, corresponding output, size of int is 4. Then size of floating point data type, and I am using size of float, I get 4. Size of double, I get 8. So for a floating point, even though both these are float and double, both are real numbers, both are used for creating real number variables or real variables to store real numbers. Float is given only 4 bytes of memory, double is given 8 bytes. That means in a double variable you can store very large numbers compared to a floating point variable. That is the difference between floating point type and double type, essentially real numbers. Then size of a character, the last one, size of char is 1. Only 1 byte is given in this computer. If you take some other computer, those who studied this thing as programming before, you must have worked on old computers or the compilers, or like little bit old compilers. they used to reserve 2 bytes for integers. 2 bytes for integers. But these days, most of the machine allocate 4 bytes for integer. So how many bytes will be reserved when you create a variable depends on the computer architecture, the system, the computer system. So typically, if it is a 16-bit machine, and the computer architecture is categorized 16-bit machine or 16-bit architecture, 32-bit architecture, 64-bit architecture, etc. On a 16-bit architecture, typically 2 bytes are used for an integer. On 32 bits and 64 bits architectures, normally 4 bytes are used for storing for an integer, storing an integer. Okay, so that's what size of a data type. Again, these primary data types, we have seen the primary data types: integer, character, floating point, double, and void is also there. I'll come to that eventually. This primary data type, especially integers, there are some modifiers also. So integer data type used for normally for storing integers. Some modifier keywords are also there. We can apply it before int. So example is short int. Another example is long int. Another example is unsigned int, unsigned short int, the unsigned long int, etc. Normally these are not used in the program. We will be happy with integer only. But some programs, very specific requirement, we will use short int, long int, etc. So in our lab, most of the time we will not use any modifiers. The bare integer int type will be used in most of the program. Okay, except that you want to specifically use. So what difference is, when integer is 4 bytes and you have a program where you don't need so large numbers, maybe the numbers are between say 100 and 200, all the numbers you are going to use are 100 and 200. You don't need 4 bytes for storing 100, any number between 100 and 200. So we want to efficiently use the memory. What we can do is we can create a short int. In that case, the number of bytes reserved will be half of the number of bytes reserved for an integer. So if integer is having 4 bytes, short int will be having 2 bytes reserved for that. We can see that here only. I update it with the modifier short space int. Instead of integer, I update it with short int, and see size of int is actually short int is 2. Previously it was 4, now it is 2. That means our program requires only, in our program we need to store only small numbers. We are using only small numbers. Why reserve 4 bytes and waste our memory? So we want to efficiently use the computer memory. For that we can use short int. Now long int, we want to use really large integers. Like integer will typically have 4 bytes, but we have large integer values in our program which is not possible to store in a typical integer having 4 bytes. In that case we can create long int. So long int, we will see what is the size of a long int. Sometimes, yeah, it should. What did I compile? Okay, for a long int also, it is, this one is the compiler I am using. For a long int also, it is not allocating extra memory, it is giving only 4 bytes. Okay, sometimes it will give double. In a 16-bit machine, when integer is 2 bytes, it will typically give 4 bytes of memory if you are using long int. Okay, here it is not giving any difference. Since it is already a 32-bit machine, 4 bytes are there. Normally 4 bytes. If you want to store still large numbers, we can use double type, or floating point numbers also can be used for large numbers. Okay, anyway, integers are a subset of real numbers, so we can use real variables also in that case. Okay, then unsigned int is for storing if your numbers, if the data you want to store in the variables or use in your program are only positive numbers, you don't need to use integer. Integer is used for storing positive as well as negative numbers, but if your program is having only positive numbers in the to be processed, then you can create unsigned integer variable. Then unsigned short int, it's a combination of unsigned as well as short. Unsigned long int, it's a combination of unsigned as well as long. So these are some modifiers to the basic data type integer. Short int, long int, unsigned int for storing only positive numbers, then unsigned short int for storing small positive numbers, unsigned long int for storing large positive numbers, like that. Then for character also, signed character, unsigned character, etc. is there. Floating point, float double and long double. Along with the double, we can have one more modifier called long double. Okay, so it is expected to allocate double the memory of memory compared to a double type variable. Let's see whether our compiler is allocating. So as of now, for double, 8 bytes are allocated. Let's see for a long double how many bytes will be allocated. 16 bytes. So for a long double, 16 bytes of memory, that means very large numbers, real numbers you can store in a long double. Okay. So these are the modifiers to your data type. Okay, then so almost most of the things I have already explained. Integer, there are signed integer and unsigned integer. Typically, when you create a variable index, by default it's a signed integer. You can store both negative and positive numbers. And if you create a variable of unsigned integer type, it is expected to store only 0 or larger values or positive values. 0 is also considered as a positive value. So 0, 1, etc., 2, 3, etc. Okay. Then when we are using signed integers in the memory allocated, say 2 bytes allocated for that, 1 bit will be used for representing the sign. Okay. So when you are storing, I will show you the memory architecture. So when I created int x is equal to 1, it's actually a signed integer. I can store -1, -1 or positive 1. So to represent whether a number is positive or negative, 1 bit, see this bit, the first bit, this is the first bit. The first bit will be used for storing the sign, and if it is 0, the sign bit is 0, it is used for representing positive numbers, and for negative numbers the sign bit will be 1. Typically for storing negative numbers or representing negative numbers, indicating negative numbers, 1 bit is used in the computer memory. That will be the first bit of that variable or first bit of that number stored in the memory. For 0, for positive numbers, 0 is used as the sign bit, and for negative numbers 1 is used as the sign bit. Okay, so any doubts so far? Basically 5 primary data types: integer, character, double, float and void. And when you create, these data types are used for creating variables. When we create variables, some memory is allocated in the some space is allocated in the computer memory, typically 2 bytes, 4 bytes, 8 bytes, etc., depending on the data type. Okay. And for unsigned for signed numbers, negative or positive numbers, for representing that, 1 is used for negative numbers, 0 is used for positive numbers in the computer memory. Okay, so I think any doubts so far? We'll stop here. Any doubts so far? Unsigned character, basically we don't want, if when it says character data type, it is actually internally an integer data type. Okay, so you see integral type, in that integer and character is there. So character data types, internally it is an integer data type of 1 byte size. So when you create a character variable, there also one bit will be used for storing the sign. So if you don't want that bit to be used for storing the sign, all the 8 bits you want for storing the magnitude only or the character value only. In that case, we can declare unsigned char. So internally, it is a number only. It's a binary sequence. It's as good as a number of 1 byte. So we don't want sign bit to be used there. Reserved. In that case, we can use unsigned char. Okay, actually 7 bits are required. Actually storing ASCII values, only 7 bits are required. Okay. Sometimes unusually if you want to exceed ASCII values, ASCII symbols, then we can use unsigned char. Otherwise, character is sufficient. Okay, with that, anything else? Did you understand? Hello? No, this is not the nodes. These are the PPTs. It is essentially same only. Maybe some additional this slide is not there. Otherwise, uh, these PPTs are the concise version of the notes. Okay, all the contents I am displaying here will be there also. Okay then, anything else? We'll stop for the day. We can proceed for the next class. We are going a bit slow. We need to maybe speed up. If your concepts are clear, later in subsequent classes we can go much faster. Thank you. See you in the next class.